This lesson, we're going to talk about flow charting, repetition. We'll have a few examples. You've already seen flow charting when we talked about algorithms, specifically algorithms. We said that there was 3 different ways that we normally do algorithms. One is just with plain English. Another one, which is related to plain English, is pseudocode. Pseudocode used to be called structured English. So it's English with special sort of rules. And then there's flowcharts. Flowcharts are nice because they're graphical. What's really good about graphical is like the IKEA algorithm, I guess you could say, right? IKEA instructions. Yeah, the manual. What's good about the IKEA manual is you don't need to be able to read Swedish to be able to do it, right? You just look at it, kind of makes sense. Doesn't matter what language you got. So here we're going to learn by example, I guess. Imagine that the Supreme Committee, whatever they are, something to do with Supreme stuff, I suppose. They are very concerned about World Cup 2022, and they need to have some kind of marketing campaign, and you were involved in that marketing campaign. Part of the marketing is to develop some kind of mascots. So mascots should be compelling. People should be able to relate to it, but it should be simple enough that it's also easy to reproduce and easy to recognize. So we don't want sort of too much crazy colors and stuff like that. We don't want too much crazy detail. And actually, when I say that, something should trigger in your mind straight away. We don't want too much detail. That sounds like abstracting, right? And I guess you could say that a mascot is kind of an abstract idea, isn't it? We take a sort of a complex idea, which is all the things that are related to Qatar celebrating the 2022 soccer tournament, and we want to reduce that down to something that people can recognize immediately. And a flag is an abstract, isn't it? It's extremely abstract. Got a couple of colors and a bit of shapes, and it's it means a lot, but without being, but it's also easily to reproduce. So that's what we want. We want something easy to reproduce. So we got these plain colors, block colors, easy to recognize sort of images there. The other thing is using Lego. Lego's got standard sizes that can block together, and so you can build things that are big out of small. Anyway, so the idea here is, I hope that we're not sort of stretching this too far, but maybe we could apply a lot of our other computational thinking to this problem. So the problem is big, and we break the problem into smaller components and get different people to approach the different components. That's typically what happens in project management with any kind of planning. Decomposition is a computational thinking concept. Pattern recognition. So we're using little Lego blocks in this particular thing. And Lego blocks are good for pattern recognition because you have Lego blocks with two sort of connectors on them, and some with 4, etc. Abstracting, I hope I've already discussed how this is all about abstracting, right? We're really trying to make something simple, recognizable, without too much sort of complexity in it. Algorithm. The idea of the algorithm comes in with the planning, I suppose, here with the creation. If we were to try and say, okay, well, we got all these ideas, we've broken it down into smaller parts, we're looking for some patterns, we've abstracted a bit, then we want to go ahead and complete the project. That's going to take some planning. Your planning is going to end up with some step-by-step things. Some things happen before other things. There's going to be some rules applied. That would be an algorithm. And you could write pseudocode to do it, I suppose. Anyway, so there's some notes there. Hopefully those notes help you in some way. So if we're going to talk about flowcharts, we do talk about algorithms because flowchart is a type of representation that we use for an algorithm. So as this slide says, which you've seen before, this slide came from a previous lecture. An algorithm could be in one of these 3 ways. Perhaps there's other ways too, but for us, we do plain English, pseudocode, or a flowchart. Each of those could be a way of representing an algorithm. And there's also mentioned the IKEA furniture. Here's some examples of problems to which you could apply an algorithm. So for example, if you wanted to convert between different units, and so we've got a good example, a good place to do that. If anybody ever has any dealings with the United States, you know that they use an older version of units. They haven't converted over to metric like the rest of the world has. So for example, their temperatures are in Celsius in the rest of the world, while in the United States only, they're in Fahrenheit. And so you'd have to be able to do the conversion. You could do that as part of an algorithm. You could say, okay, input the temperature in Fahrenheit, subtract 32 and then multiply by, 5/9. And you could get your temperature in Celsius from that. Or you could do it the other way around, right? Computing an average of anything, computing. This is a fairly simple mathematical concept, isn't it? You get the totals and you get the count. You divide the total by the count, and there is your average. Sorting. Now, sorting and finding a number, we're going to talk about these two a little bit more in your diploma course, your degree course as you go through. With regard to the idea of efficiency, efficiency is a big deal in computing, especially for computer science people. We really care about efficiency. It's the reason why we use computers, to speed things up. And there's a great opportunity to have more efficiency or less in our sorting or our searching. So finding something would be a search algorithms. And so you as a computing person would want to be doing things, you'd be wanting to write your algorithms in the most efficient way. And there's actually some science that you can apply to that. And I'm not going to go through that science here, but just to say that that is something that you will spend some time on as you go about sort of designing your algorithms. So basic flowchart. This diagram shows just in the colors are not relevant, by the way, but the shapes are. So it's showing some shapes that we use for flowcharts. We've got connectors, which are these things with the very, very rounded edges. They're actually oval. Our rectangular boxes represent processes. Our diamond boxes, they represent control selection. Or you could say that's going to be a if then else, or some condition which is true or false, depending on, we also call it branching, so we're going to go one way or the other depending on what's happening inside this condition. Now this one here we haven't talked about before, but we can use that. That represents some kind of a printed output. If we print a report or print something, then we can use a symbol like that to represent it. We're going to be doing flowcharts today, in a few minutes, or in the tutorial. So maybe we won't have too much time. I might do a couple today. So yeah, flowcharts. What's really good about flowcharts is the symbols mean something. So the idea is you can look at a flowchart, and by understanding and recognizing the symbols, you'd be able to understand quickly what that flowchart does without having to sort of read a lot. And so yeah, let's look. Oh, also. So there's a process, and this probably come up in the quiz or the test, right? The process is what people tend to do is at a high level, after we've done a lot of abstraction, our algorithm will represent it as a flowchart. Once we've represented it as a flowchart and we've sort of desk checked that, we've gone through and tested it in our minds with some examples, then we can go and write some pseudocode. And then from the pseudocode, we can translate into programs. Okay, so we usually do the flowcharts first, then pseudocode, then programs. Can you understand this? Just looking at it. If it's got a rounded edges, then that means it's a connector. It's a start or an end. So we've got one of them there and one of them there. So start, end. If it's got these kind of edges, that means it's going to be an input or an output. So that looks like an input. This kind of symbol. Decision, yeah. This is a, try again, Renee. That's a process. Anything that's got a rectangular box is a process. Okay, so tell me what happens in that flow chart. Taxi is more expensive than the metro, right? I think you can ride across Doha for a couple reals. I don't know. I've never been on the metro, but and I don't use taxis that much either. But yeah, I think the metro. So I mean, I think the metro is cheaper, but maybe it takes longer. Would that sound right? Well, it's actually fast going through town, but you know you have to walk to it, and then you have to catch your whatever connector you got. I think the metro is actually pretty fast once you get on it, but it's all the connections associated with it that takes some time. So we got the metro, or we got a taxi. Taxi, the benefits in the taxi is it's going to come right to your door, right? Guy's going to toot his horn. You just walk out into the taxi, relax, drops you off exactly where you want to be. No walking around, no catching buses or anything like that, right? So the taxi's a bit more convenient, but it's going to be a bit more expensive. So it might be faster, depending on where you live, right? If you live far away from a metro station, this is going to be faster. So why would they have this, or what's the purpose of this flow chart then? With that sort of background that I just sort of gave. Hi, Susanna. Hello. Susan, not Susanna. I think it's about time. And the reason why I say it's about time is because if you look at our decision box, it's about time, right? If you wake up early enough, then you'll catch the metro because you got enough time, right? And if you don't wake up early enough, well, you just have to get that taxi and pay more money. And so does that make sense? Yeah. Here's some symbols. And what do they mean? So we have this, I call this a connector. It calls it a start or stop, but it could also be the bottom of a page going to the top of another page. Process, going to have square edges or rectangular, we could say. Decision is going to be this diamond. The thing about the decision, it's going to have one input, one arrow coming into it, and two arrows going out, right? And the two arrows going out will represent true or false, depending on what is the condition inside the decision box, right? So the decision box will be something is true. If it's true, that's yes or true. And if it's false, it's false or no. Input outputs can be, they look kind of like a process, except the corners are not 90 degrees. And we have little arrows to connect them. They all must be connected. Now there's a link there. We're going to go and look at that in a minute, I suppose. But there is a tool that is online, which is free. There's so many online tools that are free now. So if somebody's got a server somewhere and they put the software on there, you don't even need to download the software to your computer. So all you need to do is access the site on their website, and then you can use their software and you can save it to your computer. So that's the idea. So you do need to have some kind of login credential. So for example, they'll ask you to log in with your Google account or your Facebook account or something like that. But we're going to look at that in a minute. All right, what about this one? Tell me, this is the other thing about the flowcharts. They should be simple enough that people who aren't computing people can look at it and understand. So here would be a flowchart that somebody like a security guard at the supermarket or the shopping mall, they would understand this flowchart. I think they wouldn't understand it. Maureen says they wouldn't. Okay. Anyways, so they would start here. This looks like a process. Greet customer, whatever that involves. They're going to ask them for, see the input? The input would be, show me your address. That's the input. I can see it's either green or it's red, right? Or it's yellow. If it's green, see, so do you see this is the condition? Green with a question mark. If it's green, then yes, then, oh, you can come in. If it's not green, no, you cannot come in. So hopefully that makes sense. And actually, it's a process that we've all seen and done, I suppose. There is this TV program, which I think I've seen like 2 minutes of. It's not really my type of thing. Maybe it's yours. I don't know. There's this thing called Big Bang Theory. And it's kind of kids that are your age, kind of smart people. Like this guy's like some astrophysicist or something like that. But he's smart, but he's socially awkward, right? Doesn't have many friends. And that's because he's smart. Now, there's some people that are smart that do have friends, right? But now this guy is, he's a little bit awkward. Anyway, so he wants to make some new friends, and so he made himself a flowchart for that. And so what does he do? He makes a phone call to some people. If they're home, he asks them if they'd like to have a meal. And if they'd like to have a meal, then they eat together, and then maybe they become friends. But if they don't like to have a meal, he's going to ask them, do they want to have a coffee or a cocoa or something? And, if they want to have one of those, then maybe they're going to sit down and have coffee and become friends. And if they don't want to do that, he's going to ask them, well, what are you interested in? And if they're interested in something that he's interested in, then maybe they can become friends over that. So yeah, awkward guy likes to have friends. Most people like to have friends. Not everybody, but yeah, anyways, so awkward guy maybe get some friends. So as you see, as I said, he's a smart guy. Sheldon Cooper, PhD in astrophysics or something like that. Yeah. Anyways, that's his flow chart. It was a little bit of a funny one, but yeah, I hope you got the idea there. Did you see all the decision boxes back there, right? So, depending on whether they said yes or no. If they said no 5 times, then you end up without a friend or something. LOA, whatever that means. Oh, I don't know. Why don't we do that? Yeah, I don't know. Anyways, here's another one. Let's say you have 3 marks in your course. You have a mark for a quiz, you have a mark for a test, you have a mark for a assignment. Is assignment? Yes. We take those marks, we add them together, we divide them by 3, and that's our average mark. Seems good, right? That would be our average mark for those 3. Problem is, it is actually a bit of a flawed idea, because that would give the average mark, the weighting of each would be the same. So we'd add the marks together, divide by 3. The weighting of each of them would be like 33% of the total average mark. And that's not really typical for having a test and a quiz and an assignment. Typically, we have more of the grade comes from the test, and less of the grade comes from the quiz and the assignment. So we could take this idea, instead of dividing by 3, which would assign 33% to each of those 3 things, we could assign a more carefully thought out and precise percentage. So we can say, okay, well, an assignment's going to be 20%, a quiz is going to be 30%, and the test is going to be 50%. And that adds up to 100. So now we don't have to do any dividing. So we just ask them what's their grade, we multiply and add the grade and their percentage, and then we'd get a weighted average, which would be a better number. That's basically how we do your GPAs here, if you're interested. Okay, now we're supposed to do a flow chart, which is step-by-step process for accessing your course syllabus sheet. Well, your course syllabus sheet is on D2L. So if you went to D2L and you just went to the home, so let's say that that's what happened, is you just landed on D2L, you're at home. What you do is you'd notice that you've got a menu at the top there. And probably if you looked under content, you'd see that you got a table of contents there. And if you went under general, there's your course syllabus. So in 3 steps, we can kind of get there pretty easily to find the course syllabus. So how would we do that in a flowchart? So just watch this, because I'm going to ask you to do this flowchart thing yourself. This is what you're going to do for the tutorial exercise, and this is what you're going to do for the lab. is you're going to do kind of what I'm doing now. Okay. So I'm showing it to you now. What you're going to need to do is you're going to need to navigate to this tool, which is an app on a server on the internet, right? And now I think the easiest way to navigate to it is just draw.io. But you can see that you could also get to it by going diagrams.net or app.diagrams.net or whatever. But I think draw.io has got less characters, so it's easier and quicker to get there. Yeah, there it is, app.diagrams.net. Now, I've already signed into this one and I've got an account. If you haven't got an account, you're going to have another couple of steps before this where it'll ask you to sign in. When it asks you to sign in, just choose that you're going to sign in with one of your accounts that you use, one of your social media accounts, right? With Google or Facebook or whatever. So when you've got that, I'm using OneDrive. And that's the other thing. It'll ask you, where do you want to store your data? Now you can store it on your hard drive, or you can store it on OneDrive. OneDrive, yeah, everybody's got a OneDrive account, right? Comes with your Microsoft. So I'm going to create a new diagram. When you go to choose to create a new diagram, you got lots of diagram choices there, right? You got a flowchart there is one of them. But the point that I want to make on this is you can use this tool for a lot of your stuff you're going to do in your diploma degree for the next few years, right? You're going to have to be doing a lot of these different diagrams. You're going to have to do flow charts. You're going to have to do entity relationship models. You're going to have to do, well, these others are more business models, but you'll probably have to do data flow diagrams as well. So, and yeah, you see software. We got a lot of software diagrams there too, right? We got flowchart diagrams. They've got some examples there, or you can just go and do an empty model. I'm going to go, let me close that again and create a new diagram. I'm going to do a blank diagram. So I'm going to choose a blank diagram because otherwise now at this point, as I said, this is because I've already created an account. If you haven't created an account, there's a few more steps, but those shouldn't be too hard, right? It's just, use your Google account number or whatever. So this one is asking me if I want to. So because when I create a new diagram, I should give it a name. So what would this be? This would be the course outline thing, right? So let's just say course outline. Now I can save it as an XML file. Not much else I can do. Oh, I could save it as a bitmap image. All right, well, or a PNG file. I could save it as that. That's good because then you can upload a PNG file. So there's my thing. It's going to be a course outline draw.diagram. All right, so I'm going to create that. It's actually going to create this as a blank document, but that's okay. Come on, create when you're ready. How many times do I have to do this? Yeah, okay, so, right, there we go. So I got it there now. Now, when I've got this, I've got some tools that are available to me. And what I want to do is I want to have some tools that relate directly to flowcharts. These actually look like flowchart tools, but just to make sure, I'll go and I'll choose flowchart. And there's my tools there that are available as flowchart tools. And, I've got them beside there. Over here, I've got my space where I can put stuff that I want. I want to start and stop. That looks like a start stop. So I'll just click and drag, double click on it. And right. And then I'm going to navigate to the menu. So I need a process. See anything there that looks like a process? Where are you, Mr. Process? There's lots of sort of weird shapes in this one that you don't really need. Really? Come on, the process should be okay. So that's a function, predefined process. Oh, this will do as a process. Yeah, that'll do. So that's going to be navigate to main menu. Now The reason why I didn't see that immediately is because usually I have it a bit more like that. So actually, I'm going to have several processes. They're all kind of the same. We do, but I'll do them after. So I'm going to copy this with a Control-C, and then I'm just going to Control-V, make some copies of it, right? Because I'm going to do this a few different times, right? And have 2 or 3 of these for, I don't know. I don't feel like doing yeah. They're kind of all in a line. Then I'm going to edit them. So navigate to the main menu. Then what did we do from the main menu? We're going to navigate to content. Was it in content? I think so. And then navigate to general. And then lastly, open the course. What was it called? Course curriculum or something like that. And that's it. And then afterwards, I'm going to start. There we go. Got that there. And you can squeeze and pull and, play around with those as you like. The question that I had was, well, what about the arrows? So you'll notice when the arrows are up here, we can change the shape of the arrows and play with them. You also find arrows down here sometimes. Now, also the arrows if you don't want to have, if you want them to be a bit curly, that's a nice one. I kind of like that. But do you see when I go here, there's a blue arrow. So I'm going to click on that, and that's the wrong direction. So what happened here? Let's get rid of that arrow, but you get the idea, right? So I'm going to just click on that. There's my arrow, got him, right? So it's just kind of like that. I just find the arrow between them, and there he is. And wrong direction. Well, I don't like that. There we go. So I got my arrows going between them. That wasn't too hard. And there's my very simple flowchart. Okay, yeah, the good point. Input output looks like a process. I guess you could say it's kind of a simple process in itself, which is just getting some input or making some output. Whereas here we're doing something. Yeah. Think of a process as something that you would describe with a verb, and output could be described by a noun, I suppose. Report. So when you've got that done, one thing you can do with it is you can actually export it, I think. So where's my file menu? File menu. Don't want new. Save as, there's export. So you can export it as a PDF or a PNG file. So if I export that as a PNG file, then I can say where I want it to export to. And then I have that file available. You see, it's called course outline.png, or exists because I saved it as a PNG. But if you'd done it as a draw.io, now if I go to my I put it into OneDrive. Where are you, OneDrive? There. And I put it in the root, I think, or not. Well, that's not what I was expecting. I was expecting actually to. All right, so I haven't set up OneDrive. Oh, that's amazing. Actually, I should do it on. I don't know. I have two OneDrive accounts. I have one which is my personal OneDrive account, and I have one which is my college one. I don't know which one to use here. Let's see. Can you do what? Yeah, okay. Word document. If you can, so you could take the picture and save it into your Word document file. Is that what you asked me? Yeah, there's probably some tools in Word that you could use. So, I mean, they want you to log in all the time and stuff like that. I know that's kind of a pain, but the thing is, with all that logging in, that means everything is actually saved on the cloud somewhere. So that's the idea of OneDrive, right? It's saved on the cloud. It's not actually saved. Well, there may be an artifact of it on my folder here, but yeah, okay. Get the mobile app later. Open my OneDrive folder. All right, so there's my OneDrive folder. Do you see it here? Yeah, there they are, Lab 4. Oh, I don't know. I don't know if that's, I didn't think that I had a, I thought that I just named it. Let's save it there. That's Lab 4. That's what I did in the previous class. So I'm probably logged on to the other one. Let's try this again. I don't know. The file has been modified. Click to synchronize. Anyways. All right. So can I see it now? If I can't see it here, it's in my other OneDrive account. But here's some, yeah, it is. I'm sorry. But yeah, you can save it there and use it. What you're going to open it with, right? So these are saved as PNG files. So you can open them with Paint. That's one that I did for the lab. So you'll be doing something like that. Yeah. So once they're saved, you can upload them, and that can be your assignment, how you do your assignments for the lab. So I mean, I just showed you the lab. All right. So that was just quickly. Sorry to take your time on that, but that's a nice tool. Somebody asked me, could we use a different tool? So you could use some drawing support in Microsoft Word. I don't have any problem with that. Also, there's other tools that you can use with Microsoft. You could use Visio. The reason why I'm recommending Draw.io, it's free, totally free, and you can use it anywhere. It's on the cloud. All right, so getting back to this, let's finish our little lesson. Algorithms have instructions in them. Algorithms have input and output. They have constructs. Constructs would be things like sequence. One command happens after another command, depending on the order in which they appear in the algorithm. So that's sequence. Then we have branching, which allows you to have a condition, and based on the condition, you'll either go the yes direction or the no direction. Branching is done with if then else. So you'll see that in a program. We can also use a modified version of that, which would be a do while. So that would give us iteration. So we've got three main constructs that we use. And as I spent a bit of time talking about in a previous lecture and a little bit just now, is we don't just want our algorithms to be correct. We want them to be fast and efficient. And we spent a lot of time sort of thinking about that. So here's an example of something that's not fast or efficient. You had a punishment wherein you had to write something like, I will not do this anymore. And maybe you had to write that like 100 times. That would be a punishment of repetition. And the idea is it's kind of soul destroying. But the thing about that is, as a computer person, you'd realize, well, I can get over that problem pretty easily because I can use a repetition construct to sort of handle that repeating for me and make it a lot more efficient and fast. Here's that described by this guy, Corrado, Giuseppe Jacopini. All right, so sequence, repetition, and selection we were just talking about. Repetition, doing things over and over again. If we could do that somehow in the code, if our code can handle repetition, we can save ourselves a lot of work. So here's our punishment. I will not cheat on my assessments. Please write this on the board 100 times. Boring, right? What if you could just, instead of writing that on the board 100 times, have a little app that does it? You only have to write it one time, and it does a copy paste the other 100 times. You could have a loop. And the loop would kind of look like this, right? I will not cheat on my assessments. Something's missing here, which is the control, which would be the diamond, which says, you know, have you done this 10 times? And if you have, then finish. If you haven't, then don't finish. Okay, so let's put that in there. Let's make a new file. Blank diagram again. And yeah, we'll put in the root tire. Okay, because I keep doing the wrong name. My mistake. Oh yeah. So give it a name. What's this one? This one is punishment. Let's call it punishment. You need to give it a name. And I really should, before I go any further, I should actually save it as a PNG. And now I'm ready to create my thing. Come on, slow. Did it create this time? Come on. Yes. Or exists. Do you want to replace it? Okay. There we go. And so we're going to do punishment. We're going to do our start. Now, we could just write, I will not copy, you know, like 100 times. Now, that could be an input or an output, could be like this. I will not copy. That could be my thing, right? So that's my punishment. I'm going to do that 100 times. Now, the easiest way to do that, well, I mean, I could just copy, paste 100 times, right? I just do that. But that's not really very nice, very efficient. Why not instead do something like, let's get a count. Count takes a value of 0. Then we're going to print, I will not copy. I don't know why I'm a bit tired, but I shouldn't be. It's only 3:30, right? Count. Then what we're going to do is we're going to increment the count. So this is initializing the count. Then we're going to increment the count. So we're going to have another count here. Control C, Control V. Now we're going to have count is equal to count plus 1. Come on. Yeah. That's incrementing the count. And then we're going to have a decision, which is, you know, count is less than 10. And if the count is less than 10, we're going to go back and we're going to print again. All right. So I'm going to need my arrows for this. Where's my arrows? Every time I look at this, it's got a different menu, right? Look at that. Where'd the arrows go? Well, we got some arrows down here. Directional connector. This one here is a nice arrow. Anyway, so I can take an arrow from here and I can make it go back up to here. Yeah. Now I think is that pull it out here so it doesn't look so ugly. And it still looks ugly, but you know, it's a little less ugly. Oh, well, you get the idea. So the arrow is going back, right? Now I've got my other arrows coming down that don't go back. So this is the no error. All right. So this is the yes arrow. So if I double click on that, I can type yes. So if the count is less than 10, I'm going to go back and print I will not copy. Now the other ones here, I'm going to put those little arrows in there. There's an arrow there, arrow there, arrow there, arrow there. All right. And if the count isn't, so this is the no, right? If the count is no, then it's going to be, look at that. That's cool. You know, did you see they have those symbols sort of floating below? And if I just clicked on them, the connector went with it. And so that's a finish. And so that's a more efficient way of doing that. And of course, as I said, you could save that and you could export it as a PNG, blah, blah, and put it in your OneDrive or whatever. And that's going to be called whatever. Okay, yeah, it's already, I'm going to replace it. But there's my thing, right? Now, how would that look? You've got this thing called idle. You're going to be doing computer programming a bit later on, not today. You don't have to do this, but I'm going to show it to you. No, sorry, you're not supposed to open up the browser. It's supposed to come straight from the computer. That's it. There's idle. And with idle, you can make a computer program. So this is the punishment program. And so what we do here is I'm just going to take the flow chart, and as if we had a pseudocode, I'm going to make a program out of the flow chart. Count 0 while the count is less than 10. What we're going to do is we're going to print and then I'm going to increment the count. So what will happen? It's fairly simple, right? 3 lines of code, 4 lines of code. So it does that 10 times. And that's the algorithm for that. Now, if you weren't sure that that was working, I can print the thing. So really the efficiency here is, right, so all I had to do is write those 4 lines of code and I get 10 lines out. What if I needed to do it 100 times? All I have to do is add an extra 0. Now it'll go 100 times. I will not copy 100 times, right? Or it could be 1,000 times, right? I mean, so this is the power of the computer, is that we can repeat things and we can repeat things quickly. I will not copy. All right, 780, 999. Okay, get the idea? So yeah, the code is 4 lines of code. From my 4 lines of code, I got 1,000 lines of printed stuff. So I think you can see that that's more efficient. And that, if you can, then that's the idea that I wanted you to get. So we can do things a lot more efficiently. Yeah. All right. So that we took this little flowchart, which was missing something, and we put that in there, right? And when we put that in there, yeah, so we put that was this bit here. And sorry about my arrow being across a very bad shaped arrow. Yeah, maybe I should delete that arrow and get another one, right? All right, but it has to go from here back to here. That's the problem with it. Yeah, so whatever, but it's going back, right? But what we see with that is, oh, actually, no, I've got a nice one here. Yeah. Let's do that again. So now I've got a nice one here. So I can cross that out, and there we go. Now it works. And just pull that across there, maybe. Come on. Oh, man, there we go. That's better, right? Yeah, that's better. So yeah, we're just going back. As long as it counts less than 10. That's our nice little flow chart that sort of does that. And that gave us our nice little program. And that, folks, is all we had to do. Oh, we got one more. Happy birthday to you. Very similar. Very similar. Actually, I could take this flow chart and yeah, instead, okay, what we're going to do is, oh, should I do a new one? We got another hour, right? This is the last thing we'll do. Last thing we'll do. We're going to make another one. It's going to be the happy birthday to you thing, right? So blank diagram, it's going to be the happy birthday one. and I'll make it as a PNG. The happy birthday. Okay, blank diagram coming up, right? Oh yeah, it's gonna say, yeah. I don't know why I have to do this twice. It's just weird. Come on, get out of the way. Get out of my face there. Okay, now we're gone. Oh, right. There's a free software, right? So, I mean, maybe I can just open up. Now I need to, maybe there's a happy birthday that I've just created that I can open up. Oh, God. Excuse my, no, I don't see it. Excuse my frustration. Happy birthday. HB, let's just call it HB. So that's my happy birthday. I'm not going to do the bitmap image. I don't know if that was what caused it. Yeah, okay. So give me an empty folder. Come on. There we go. All right, so start. We got our HB thing. Now what's going to happen here is we're going to get input from the person. We're going to get their name and their age. Get their name and their age. And then what we're going to do is we're going to do the counter thing again. So can you do what? Can you do it as a function? Oh yeah. What is your, yeah, why not? But when we write the program, it'll be a question. So here we're initializing our counter. Now we're going to print happy birthday and a number, right? So we're going to print the happy birthday and an age. So that's an output like this. Say, we'll print their name and the count. So that can all happen in a, gonna do that. And now we are going to increment the counter. So we increment the counter with count is equal to count plus 1. That's incrementing the counter. Now we can put in our decision, which is the count less than, so it's very similar to the last one, right? Is the count still less than their age? Because we're going to stop as soon as the count gets equal to their age. So eventually the count will get equal to their age, then we're going to stop. And so if the count is less than their age, if it's yes, we're going to go back up here and, okay, so I got the wrong, I want the curvy one. I thought I had it, but I didn't. If it's less than their age, then we're going, we did this a minute ago. If it's less than their age, we're going to, oh, come on, get out of the way. All right, so if it's less than their age, we go back and print the happy birthday thing again. If it's not less than their age, then we're going to go down here and what? We're going to go to the end. So that's kind of it. Probably you could label these if you wanted by double clicking on it. If you got it in the right place. Yeah, so that's yes. And I do have trouble on that one. Anyways, we get the idea. That's yes. Let's put our arrows on here. Arrow there and there. Yeah, got it. All right. So now we have our little program. I'll make that a bit smaller, maybe. There. So you can sort of see it. Oh, making it smaller makes it harder to see. Maybe I shouldn't have done that. Anyway, so I'll just scroll down through it so you can see. We start, we get the name and the age. We print happy birthday and the count. We increment the count. If the count becomes equal to the age, then we stop. So we're going to do that just to test it out. I'm going to do that is a Python program. You don't have to write Python programs. You do this later. The happy birthday thing, right? And so I'm going to start with the counts equal to 0. But the other thing is we need to get the age. So the age is got by an input, but it has to be converted to a number. Input is like this. So I'm going to get an input from the user. I'm going to ask them what is their age. That was what you were saying. And then I'm going to ask them what is their name. Oh, there needs to be an equal there. Takes the value of, name takes the value of. We're going to ask them this also. What is your name? And then we're away. We can start printing stuff. So that will be inside a loop while count is less than age. Then we're going to just do this stuff. We're just going to print happy birthday. Then we give their name. What do we do after that? We're gonna the number. Yeah, there. How many times, right? So that would be the count. Sorry, I am getting a bit tired. There we go. And then we just have to increment the count. Can't use uppercase. That's the problem with Python. It is case sensitive. So uppercase is very different than lowercase. Let's try happy birthday. See how that works. Not that. Kill it and run this again. All right, somebody give us a name and a birthday. I don't know. What's your age, somebody? Or I'll make up an age. I don't know. Somebody's 12 years old. Okay. And their name is, I don't know, Faisal. Faisal's 12 years old. So it's not any Faisal in this class. All right, so that was printed 11 times, 12 times if you count the 0. So you don't like the 0, we could start counting from 1, and they could make it less than or equal to the age. And so what's your age? This is somebody who's more like our student here, right? 19. Let's say Reem. Got happy birthday 19 times. Okay, so you can see that, right? Happy birthday 19 times. Fairly simple. We got printed 19 times and we got like what? 6 lines of code. 6 lines of code. We got a loop, which is doing that. 2 things happening in the loop. We're incrementing the count and we're saying our happy birthday. Before we went into the count, we asked them their age. Before we went into the loop, we asked them their age. Okay, can you see how this relates to this? Same program, right? So that's what it looks like as flowchart. And to be fair, the pseudocode would look pretty similar to the Python code. All right, I think I'm done now. If you want to have a look at the tutorial in the lab, they're there. I think I got you started on using, you don't have to use Python. Don't worry about Python. If you want to, welcome, because you will spend a lot of time later in your degree doing Python and stuff like that. So if you want to, oh, and the other thing is, so, I mean, some teachers would say, don't teach them Python straight up. They're going to fail. Absolutely. You're going to try Python. The program's not going to work. You're going to fail. If that bothers you, I'm sorry, but that's what happens to everybody when they start writing computer programs. Okay. What I want to say to you is the program fails. Don't worry about it. Right. I mean, you know, you'll get used to it. You really just have to try and fail and try and fail, try and fail. Eventually you get there. Right. So don't worry about that. You don't have to do the Python. It's not part of the course yet. It's going to come in 4 or 5 weeks from now. But I'm just showing it to you because actually part of the reason why I'm showing it to you is I don't want 4 or 5 weeks from now, you look at it and you go, oh my God, what's that? You know, how are we ever going to do that? I want you to at least say, oh yeah, I saw that. You know, maybe I could do that. And also you've seen the flow chart. Okay. So that's what I'm hoping.